Okay, we've been learning about the law of sines and the law of cosines, and one of its best applications, there are many applications. We're going to get into vectors and things like that, and you're going to encounter these in your pre-engineering courses. But what we're going to concentrate right now is navigation. And navigation means, most often, airplanes, ships, things like that that are moving in a certain direction. It can also be used to locate things like a fire, or if you had a forest fire and you had tracking stations. So all of these bearing concepts have to do with direction. And so what we're talking about then is north-south, right? East and west. And you can see that it looks like a coordinate plane. So this angle right in here is 90 degrees, right? This angle here also 90 degrees, 90 degrees, 90 degrees, because all the way around is 360. So for instance, if I have a navigation bearing that goes from the center, the very center here, and then out in this direction, right? You would say that it was from the north, this direction, theta, and it would be going in the northeast, north and easterly direction. So north and south is always first, and then east and west is second in the direction. And so this one in particular would be theta degrees north and east. So you would write the bearing between, and the theta is always going to be drawn to the north or south axis. So for instance, if I have one here, and it's 20 degrees from here to here, then this would be 20 degrees south and west. And you always put the south first and then the west. But the bearing is always going to be drawn to the north or the south, not the east or the west. And that's kind of opposite than what we did on our unit circle when we were looking for reference angles. Remember, we always drew it to the x-axis, and here you're always going to draw to the y. And so this would be just how, like, say for instance, I wanted to go this direction, right? And I said that from here to here was 10 degrees. Well, this is not 10 degrees south and east. This is 80 degrees, because you would draw the angle to the south. So this would be 80 degrees south and east. That would be this. Okay? All right, so direction is a point stated as the number of degrees east and west of north or south. All right, so north 30 degrees east means that the direction is from 30 degrees east of north. So here's east, here's north, so this is 30 degrees. This would be the vector 0 to A, right? So what we would say on here is A is what degree, what direction, what bearing from O. And so we would write A is 30 degrees north and east. And notice I'm putting the north and the east around the degrees. So B, I go over here and I find B. Here's B. B is 60 degrees from the north, right? So 60 degrees north and west from O. Okay, C is drawn, from the south. That's 70 degrees. So that's my actual degree, 70 degrees south and east from O. And then try D. Try D. Okay, south 80 degrees west. Now, be sure that you're putting the north and south first, the east or west second, and then the angle in between. All right, and notice how this is written. A is this from O. So in other words, if I start at O and I go north 30 degrees, 30 degrees east, I'm going to end up at A. Okay, and if I go from the O, the origin, south and east, 70 degrees from south, a certain length, then I'm going to go to C. And this is going to be really important that you understand how this works, because later on we'll have application problems and they're going to give you these coordinates. There's going to say north 30 degrees east, and you're going to need to be able to do the diagram. Okay? Okay, there's an alternate way to talk about bearing or courses, and this one is a little bit different. This uses a 360 degree circle, right? And you always start from the north. So for instance, this angle, O to P, is going to be 65 degrees from the north, and that's all you write. You just say 0, 65 degrees. Okay. Over here, if I want to travel to Q, then I would do this angle all the way around to here. Well, it tells me that this part right here is 60, so O to Q would be 300 degrees. And so that just tells me there's no north, south, east, west in it. It's just the angle. Just the angle. And the angle is going to be anywhere from 0 to 360 degrees. It always goes clockwise from the north. Okay, here are a few examples of using the two different kinds. Okay, so on this first one up here, this first one right here, the direction is going to be the one with the north, south, east, and west. Okay, so I'm looking here, and I know this is north, and this is east, and this is drawn from the north, so this is going to be 60 degrees northeast, drawn like that. The bearing comes from the north, so that's also going to be 60 degrees. Okay, the direction over here on this one is going to be north and west, right? Drawn from the north, so this is going to be north 72 degrees 18 inches west. Okay, and the bearing would be from the north all the way around, and so that bearing is going to be 360 degrees minus 72 degrees 18 minutes. I don't know if I can get that, yeah. And if we do that right, that should be 287 degrees and 42 minutes. And that's all that is. All right, so I'm going to work these last two, but what I would like you to do is stop the video, and then when you play the video again, the answer will be on there. Okay, so go ahead and stop it now. Okay, direction on this one is going to be west and south. So this is going to be south 35 degrees west. How'd you do? This one is going to be all the way to here. So it'll be 180 plus 35, which is 215 degrees. Okay, this one is east and south, but it's not 20. It's this angle because it's drawn to the south. So this will be south 70 degrees east, and the bearing would be this far. So this is 90 and that's 20, so it'll be 110 degrees. Okay, how'd you do? Hopefully pretty good. Okay, this looks very similar to what I've been talking about before, but when you're talking about a bearing, it's used to represent the direction of one point relative to another. All right, so for instance, if it says the bearing of A from B, right, means you start at B and go towards A. So I'm starting at B and heading towards A. So at B, I draw in a coordinate plane and I show 65 degrees, which means if I go north 65 degrees east for a certain piece of time, I'm going to end up at a particular distance. I'm going to end up at A. Okay, so if I'm going from B to A, this is the only piece I would set up. However, if I start at A and want to go towards B, you can see that that's a different direction, right? If I put the coordinate plane on top of A, which I can do, it's just horizontal and vertical, and then go 245 degrees. And then go some distance, I'm going to arrive down at B from A. So there's a difference between, and you have to know which way you're going. Am I going from B to A or from A to B? You only do one of these per bearing. So you're not going to have both of them at the same time. You'll just have one going one direction or one going the other. And eventually what we'll do is we're going to have like triangles that we set up. And then we're going to be able to find the angles based on these bearings. So the figures are used to give bearings, and bearings are all measured in a horizontal plane, and horizontal like this, from the north. Okay, so here's an example. A boat sails from a certain port in the direction of north 30 degrees west. After it has sailed 20 kilometers, how far is it west of the port? All right, so the first thing we're going to start with is the direction. So I'm going to set up the horizontal plane, right? This is north, this is east, this is west. Okay? So it says, I'm going to start here at the origin, and it goes 30 degrees north and west, 30 degrees from the north. So let me do this. This is 30 degrees. All right, north and west. After it sails 20 kilometers, all right, that's how far it sailed. How far west of it is the port, all right? So this is, I'll change colors, this is the length west. This is how far west it is, right? And this is how far north it is. So you can see we have a triangle here made of northwest, north, the direction west, and then also the actual bearing, which was 20 kilometers. All right, so can I find this angle? Well, sure I can, because this is 30 degrees from the north, then this angle would be 60, right here. And so if I want to find west, I can either use the 30, 60, 90 triangle, or I can use a trig function. And I can say, because I'm looking for adjacent, so I'm looking for the cosine of 60 is west over 20 kilometers, and solve it that way. The other way I can solve it is if this is 60, this has got to be 30. This is the hypotenuse. So west would be half, right, of that, and so this will be 10. So using a special right triangle, it would be 10 kilometers west of port. One more example. This is an airplane flies 150 kilometers from an airport in the direction of 120 degrees. How far east of the airport is the plane, and how far south? Okay, so we're not using northwest or southeast. We're using the actual bearing from the north. Okay, so here's north, 150 kilometers in a direction of 120. Well, I know to here is 90, so about 30 more would be 120 degrees. Okay, the airplane flies 150 kilometers and ends up here. Okay, this is where the plane is. So it tells me the bearing, and it tells me how long, how far it has gone. All right. So it wants how far east and how far south. So I'm going to change colors. This is east. So east goes this way, right? East. This is east. And then it wants to know how far south. Okay, so I need this angle inside my little triangle because I've made my triangle. It's a right triangle. I know that this part right here is 90, so this part right here has to be 30. Okay, so I can, once again, I have another special right triangle, but I can set it up with a trig function if I don't know. To find south, I would do the sine of 30 is the south over 150. Or I do know that the side opposite the 30 is half, so it's going to be 75 kilometers. And then east would be 75 times the square root of 3 kilometers, which doesn't tell me exactly how much that is. So 73 times the square root of 3, not 73, 75 129.9 kilometers. Does that make sense in the context of the problem? It's not bigger than the hypotenuse, so yes, I'm okay with that. Okay, here's your homework problem. Do this in your composition notebook. Use what you've learned so far. Remember that these are not just for you to copy down notes. They're also for you to begin to learn the material and think about what you're learning. Please bring any questions you have to class, and we'll go over this again as many times as you need to. All right, so be sure you have this problem in your homework. See you in class.